Okay, here is a video for you on your 4.9 motion problems. Hopefully will help you through some of the more difficult ones. Your assignment is to do 1 through 10 all. I'm going to let you do that on your own. Those are pretty simple. And after we do these, you can see why they are going to be more simple for you. Okay, let's start with number 12. 12 says, a train is traveling 62 miles per hour and has to go 372 miles. How long will it take the train to make the trip? This is a very simple equation. You use your equation of rate times time times distance to figure this out. We know that if we take the rate times the time, it's going to equal the distance that the train goes. We know some of the information. We don't know all of it. We know that the train is traveling at 62 miles per hour, and we know that it has to go 372 miles. So 372 miles is our distance, and our rate is 62 miles per hour. So that we are solving for our time. So we can put x as time or t as time, whatever one you want to put in there. The question says, how long will it take the train to make the trip? That's your first clue. How long is your time? So that clue should tell you that that's where your variable will be. So we simply just take that equation, 62 times x equals 372. And then you solve for x. X is your time, and that will be your answer. 62 times x means x is being multiplied by. So the inverse of multiply is divide. So you want to divide both sides by that 62. So you have 1 here. 1x equals 372 divided by 62. You can leave the 1 off on this step to skip a step, or leave it there and then do one more step. But 362 divided by 62, you could use longhand or use your calculator for that, and that answer should be 6. Now, it's a word problem, so you need to have a word to go with it. 6 what? It's our time. Is it 6 minutes, 6 hours? And if you reread the problem, you will find out it's 6 hours. I want to remind you again, as I do videos like this, that you should pause, try to do it yourself, and then watch and listen. If you get stuck, watch and listen up to the point you got stuck in, and then turn it off again and try to finish. Let's do 14. Sue leaves Lewiston for Clarksville, 388 miles away, and drives 52 miles per hour. Monica leaves Clarksville for Lewiston and at the same time and travels 45 miles per hour. How soon will the two meet? I think it's a good idea when you have one like this to draw a picture. It helps me. So here we have what is it called? Lewiston and Clarksville. Here's Clarksville. And we have Sue here. She's starting here. She's going 52 miles per hour. This way. And we have Monica here. And she is going 45 miles per hour. And she's going this way. All right. 52 miles per hour, Monica leaves, and same time travels 45 miles. Question is, how soon will the two meet? How soon? Right away, you should, in your head, say, hey, how soon is a time question. So pretty sure that that's what my variable is going to be, because that's what we're solving for. We want to know what time. What time do they meet up in the middle? Obviously, Sue's going to make it farther than Monica, because she's going faster. But how much faster? How much more distance is she going to cover? Well, we know two things. We know that Sue is traveling at 52 miles per hour. We know that Monica is traveling at 45 miles per hour. And then we take these. Often you want to put here, you're tempted to put here the distance, the total distance. Don't be tempted to do that. The total distance is something that's really different. It really should be these two totaled together, right? Sue's distance and Monica's distance are going to be a portion of the total distance, which I think was 388 miles, okay? You kind of have to leave that hanging there until the end, until you get your equation. when you do these, you should just look at 52 and the time x. The distance is the rate times the time, so we just times those. So it's just 52x. And Monica's distance will just be 45x. Whatever the time is times their rate is what the distance will be, because that's what our equation tells us. So now, how do we figure that out? If her distance is this, and Monica's distance is this, and the total distance traveled between the two of them from here to here is 388, you can write an equation. Think that through and try to do it by yourself. We have 52x for Sue, this amount is her distance, plus Monica's distance, which is 45x, and that should equal the total miles of the distance between the two cities when they meet here. So that is 388. So you should be able to solve this now by combining like terms and then dividing whatever this like terms is. I'm going to let you do that on your own, but this is kind of how you have to work your brain through it to get a good equation to work with. All right, let's move on and try another one. Number 15 is your next one. Let's look at that one. 15 says, Brett rides a moped down the country road in front of his house. Okay, here's his house, and here's Brett. He rides down a country road in front of his house. Brett's wife, Jan, and her two sons ride bicycle in the opposite direction. So his wife and sons ride this direction on the same road. If they leave at the same time and Brett travels at 24 miles per hour and Jan and the boys travel at 8 miles per hour, how much time will pass before they are 24 miles apart? So how much time will pass before the distance between them is 24 miles? That's the question. Do you hear that question? How much time will pass before they are 24 miles? That should give you a clue how much time will pass, that the variable is going to be your time again, because we're looking for that time. We don't know how much that time is. But we do know, don't we, what Brent's mile rate is. It's 24 miles per hour. We know what Jan and the kids' rate is as well. We know that it's 8 miles per hour. And now, just like in the other one, don't be tempted to give me this distance here. This Brent's distance is not going to be the total distance, right? Not the total of 24 miles when they're 24 miles apart. That's not his total. It's just his is from here to here. Jan's is from here to here, right? So we just multiply these together because we know our equation is r times t is d. And that's what r times t is right now. We don't know this one. R times t is d. Now, the distance from here to here, the 24 miles, we know. We know that the total is 24 miles, right? But we need Brent's distance and Jan's distance. We know Brent's is 24x. We know Jan's is 8x. And we know together that's going to equal 24 miles. All right, and you should be able to solve that easily by using your excellent algebraic skills to solve for x. And remember, when you solve for x, always plug it back into the equation. Now for this one, it's just the time, and they're both going to be the same. But sometimes that's not the case. You have to not only solve for x, but you have to plug it in to figure out what your actual answer is. Let's try one more. 23 is your next assignment, next problem. And that one goes like this. A freight train leaves Centriella for Chicago. At the same time, a passenger train leaves Chicago for Centriella. The freight train moves at a speed of 45 miles per hour. So it looks like it's going to be a similar problem again. We have two. Here's the Centriella, and we'll put Chicago over here. Okay. And we have a freight train that leaves. Here's our train. It leaves for Chicago. And then we have a passenger train here that's leaving for Centriella. I don't know if I'm pronouncing that right or not. The freight train moves at the speed of 45 miles per hour. So we know this guy, 45 miles per hour. Next information. And the passenger train travels at a speed of 64 miles per hour. That one's faster yet. If Chicago and Centralia are 218 miles apart, how long will it take for the two trains to meet? So we know from here to here, the total distance is 218. You probably could do this on your own now, hopefully. Let's look up here. Our question, again, what are we solving for? Is how long will it take for the two trains to meet? So you should say right away, my variable is likely how long is it going to take for them to meet is my time in my equation. The freight train, what is the rate? We know that, 45. What is the rate of the passenger train? 64. And again, the distances are going to be different, right? Because they're going to meet in the middle. This one's going to have a longer distance because it's going faster. Okay, where is that middle mark? We don't know. We need to know the timing of that. But we don't know what the distance is either. So we can use this to figure out the distance. We can say, well, we know the rate times the time is our distance. We don't know exactly what it is, but we know it will be this. And the passenger train is 64 times time, and is this. Now, this together is this, and that together should equal this, right? So that should give you your equation again. 45x plus 64x equals the 218. And now you can, again, solve for your x there. Let's say they asked, instead of for your time, they asked, what distance did they each go? Then you would take your x after you solved, stick your x in here and multiply it by 45. You would know the distance of the freight train. If you, when you solve for x, put your x in here and multiply by 64, you would know the distance that the passenger train went. And those two added together will equal this. All right. Good luck with those. Hopefully that helps.